Okay, so this is about 4.9, which is antiderivatives. Um, so yeah, what is an antiderivative? Yeah, so just to make it clear, if g of x is the derivative of f of x, then f of x is an antiderivative of g of x. So one of them is the derivative of the other one, and that means the other one is the antiderivative of the first one. So for example, the derivative of sine is cosine, so the antiderivative of cosine is sine. We have a table full of antiderivatives, table 2 on page 352. So I'm going to refer you to that table. We're going to use that table several times. So let's find some antiderivatives. We're going to start slow. We're just going to find the antiderivative of 2x. Of course, if you think about it, we know a function whose derivative is 2x. X squared is a function whose derivative would be 2x. But let's not do this by just kind of guessing out of thin air, because we might not always be able to guess the answer that way. In the table, there's an entry like this for powers of x. Whenever you have x to the n, as long as you're not doing the -1 power, which we're not, this would be x to the 1. Then the antiderivative is this. So here's what happens. This 2 comes right down, and then watch me do the derivative of, or the antiderivative of x to the 1. So my n is 1, so I'm going to go x to the 2, because that's n plus 1, and then I divide by 2. So these 2's cancel. And in the end, you have to put plus a constant, and we usually use the letter c for a constant. So my answer here is x squared plus c. Why is that? So this said find the most general antiderivative. We said that when we were thinking about it, we said that x squared would work. And that's right, but there's a lot of other functions that work. We're looking for any function whose derivative is 2x. And the thing is, if I add a constant, when I do the derivative, the constant just goes away. So my function doesn't have to be x squared. My function could be x squared plus 2, or x squared plus 7, or x squared plus really any constant, and its derivative would still be 2x. So that's what we mean by the most general antiderivative. Typically, what you do is you just find a particular antiderivative, and that's what the table tells you. And then when you're done doing that, you just write plus c on your answer. Yeah, so let's do that a few more times. This one is similar. It's just involving different powers of x. So this is x cubed, so I'm going to go x to the 4th over 4. You raise the power, and then you divide by that same number. Then I've got this. Okay, the 5 carries right down, and then I'm doing x squared, so I get x cubed over 3. We can even use this for fractional powers, x to the 1/2 power. If I increase that by 1, I would get 3/2, and then I would also divide by that same number. Now I've got this. I can even do this with negative powers, as long as it's not the -1 power. But I can do the -2/3 power. If I increase -2/3 by 1, I get +1/3. So that's going to be my new power. And then I divide by that same number. And when I'm done, I should write plus c. And then let me just simplify that because there's fractions going on. I've got 1/4 x to the 4th plus 5/3 x to the 3rd plus 2/3 x to the 3/2 plus, okay, so these actually don't cancel, these multiply. So 9x to the 1/3 plus c. And we're good. Okay. Let's do this one. This one may look hard, but if you just look at the table has an entry for e to the x, and of course this one we should see this one coming. We know that the derivative of e to the x is e to the x, so the antiderivative of e to the x is also e to the x. So this is just e to the x. The antiderivative of this one, if you remember, this was the derivative of arcsine, so the antiderivative of this is arcsine. So it looked harder than it was. You just have to look each one of these up in the table and put it together, and then put plus c on your answer. Okay, what about this one? This one is just, all we have to do is a little bit of algebra to put this in a form where we can do it. These are roots, like the square root and the cube root. Those are just the same as powers, and calculus is always more friendly with powers. So this is this. And if you look on the table, there's no entries involving fractions like this. I still have to use some algebra to simplify this. What I can do is I can divide everything through by this x to the 1/3, and we know what happens. You subtract the powers, so this would be x to the 1/2 minus 1/3, and then x to the 2 minus 1/3. Okay, so then what's 1/2 minus 1/3? That would be 3/6 minus 2/6, which is 1/6. And this would be 6/3 minus 1/3, which is 5/3. There we go. Now this is looking a lot better. I can do the antiderivative of this. If I increase this by 1, I would get 7/6. And I should divide that by, you always divide by the same number, and then 5/3 plus 1 would be 8/3, and then I would divide by that same number. And then I put plus c on my answer. And then let me clean this up a little bit. This is 6/7 x to the 7/6 plus 3/8 x to the 8/3 plus c, like that. Okay. So let's look at a slightly different type of example, but this is still the same type of thing. I'm going to ask you what f of x is if I tell you the second derivative of f is this. Whoops. Yeah, this should be an x. So it's 6x minus 8. And then I'm going to tell you some particular, I'm going to tell you f of 1 and f prime of 1. So here's how we do this. I have the second derivative. So what I'm going to do is I'm going to do the antiderivative twice. Because if I want to undo a derivative, what I do is an antiderivative. And I want to do that twice because I have the second derivative. So first, if I do the antiderivative of this, that should give me the first derivative. So that would be 6x squared over 2, because this is like x to the 1, minus 8x. The antiderivative of a constant is just that constant times x. It makes sense because if I did the derivative of 8x, I would just get 8. So the antiderivative of 8 is 8x. So I've got this, and I should put plus c, right? Now let me tell you, oh, well, first let's clean this up. 3x squared minus 8x plus c. Now let me tell you, we're going to be able to find c because we were told the value of f prime of 1. So f prime of 1, if I plug it in, I would get 3 minus 8 plus c. So that's negative 5 plus c. And that's supposed to equal 1. Or, whoops, that's supposed to equal 2. So c would be 7. So let me update my f prime of x with that information. 3x squared minus 8x plus 7. I still want f of x, so I need to do another antiderivative. So the antiderivative would be 3, and then x cubed over 3. This is x squared over 2. The antiderivative of 7 is 7x because that's a constant. Now I should put plus c, except I've already used the letter c, so I don't want to use, it's not necessarily the same constant, so I'll use a different letter, say d. And let me clean this up. This is x cubed minus 4x squared plus 7x plus d. And we are also going to be able to find d, because we know that f of 1 is supposed to be 1. So f of 1, if I plug it in, I get 1 minus 4 plus 7 plus d, which is 4 plus d. And that's supposed to equal 1, so d is negative 3. So finally, f of x is, okay, I'll take my answer from here. X cubed minus 4x squared plus 7x plus d, which is negative 3, so minus 3. There we go. And by the way, there's a homework problem where they do this with acceleration. Like they tell you the acceleration at time t, and they tell you that it's this function of t. Just remember that acceleration is the second derivative of the position function. There's the position function, and then the first derivative is the velocity function, and the second derivative is the acceleration function. So that's if you see that problem, that's just like this one. The acceleration is telling you the second derivative. It's like telling you f double prime of x. F prime of x is telling you the velocity function, and f of x is telling you the position function. So you would solve that one just the way we solved this one.